Hi everyone, welcome back again. We'll be looking at the part 2 of our trigonometric ratios. We have already established the basics of your trigonometry ratios. So we're starting with this question. It says the diagram shows two right angle triangles joined together. So you can see your right angle triangles, there are two here, joined together. So I would like to say this is triangle A and this is triangle B. So both of them are joined together. And we are going to be finding the value of x in the triangle. After you've gotten the value of x, you're expected to find the perimeter of the shape. That means the perimeter of the shape, you have to find the side, you have to find the side. So before we can find x, we need to find the side here. Without that side, your value of x can't be found. So how do we get that? I brought the triangle down here. This triangle is down here. So I've decided to separate it into two parts. This is the first part of the triangle. I'm going to label this triangle as triangle A. So in triangle A, if you look clearly, we have our angle marked theta as 50 degrees. Earlier, we stated that you have to look at the side opposite the marked angle. And that location is called my opposite. So opposite is labeled Y here because we already have X as the unknown in the two triangles combined. Then the longest hand we established earlier, we said is always the hypotenuse of your triangle. Then we have our adjacent side here is 5 cm. So I'm going to write out what we have. Opposite as y, adjacent as 5 cm. Then our theta, which is our angle, as 50 degrees. So what comes to mind? We'll go back to our SOHCAHTOA concept, because we are finding the side of a right angle triangle. This is the only principle we are applying here. So if you look at your SOHCAHTOA concept, we have our sine. Previously we said sine is opposite divided by hypotenuse. And when you're looking for cosine of angles, you must have adjacent given and you must have hypotenuse given. Then if you're looking for tan of angles, you must have opposite given and you must also have your adjacent given. So if you look at this triangle we are dealing with, from what we have opposite, which is y. We have our adjacent, which is 5. So what are we using for opposite and adjacent? Go back, we have our tour here. That is the only ratios that have opposite and adjacent. So, and I have angle also at 50 degrees. So we are applying tan theta, which is now our opposite divided by the adjacent given. So theta is tan 50 degrees, opposite is y, divided by 5. So I've written this, I'm looking for y. So I have to cross multiply. So having cross multiply, that means y is on its own, y is equals to 5 times 50. So we have 5 times 50 on your calculator, we press 5 times 50. So 5 times 50 will give you 5.96 centimeters. So we've gotten y as 5.96 centimeters. So our y, which is the bottom of this triangle, is already 5.96. So now we are taking the second part of the triangle and labeling as triangle B. Since we've already gotten 5.96, we can go ahead to look for our x value of this triangle. So same principle of SOHCAHTOA we are applying to this. We have our adjacent value as 5.96, and the opposite of the marked angle here is our x, where theta is 38 and the opposite of the right angle triangle is x. And our adjacent value is 5.96. So we are having 12, because 12 is the one that has opposite and adjacent. So referring to 12, we are going to use tan 38 is equals to x, which is our opposite, divided by adjacent. Our adjacent is 5.96. So same thing, we have to cross multiply. So we have x is equal to 5.96 multiplied tan 38. That means x is equal to 4.66 centimeters. So we've gotten our opposite hand of triangle B as 4.66 centimeters.